Welcome, ladies and gentlemen. So what I'd like to do is show you how to evaluate three different expressions of the half angle. So we're going to evaluate sine of u over 2, cosine of u over 2, and tangent of u over 2. And to do that, we're given an equation and a constraint. And the equation and the constraint is everything to help us be able to evaluate these three expressions. The reason why is because previously, I gave you a triangle or I gave you an angle, and we could easily just plug in the half angle formulas and evaluate. But the problem is here, we don't have any ratio. We don't have any triangles or any values. So what we're going to do is we're going to use the equation and the constraint to help us develop a triangle, because we just can't draw a triangle based on what sine is, which is opposite over hypotenuse. We have to base that triangle off of the constraint, which is 3 pi over 2, or u is greater than 3 pi over 2, but less than 2 pi. So to understand how that's going to change, let's go ahead and draw with the constraints. So if I had a coordinate axis here, and if we were going to draw some angles, we'd start at 0. And if we kept on rotating, we'd get to pi over 2. Kept on rotating again, we'd get to pi. Continue that rotation, we'd get to 3 pi over 2. And if we rotated all the way back over to where we were, we'd get to 2 pi. So again, our angle u, they're saying has to be between 3 pi over 2 and 2 pi. That means our angle needs to be contained in the fourth quadrant. Might have been easier for them just to say the fourth quadrant. Yes, some problems do. Some problems like to say it like this, though. So remember, when you're creating an angle in that fourth quadrant, it has to be a central angle, meaning your vertex has to be at the origin, and that right triangle is going to need to be perpendicular to the x-axis, creating your 90-degree angle. Now we have our right angle. Now remember, just a quick little review. The side length that's opposite of your right angle is what we call our hypotenuse. The side that is between your angle and the right angle is your adjacent side. And the side that is opposite of your angle is your opposite side. Now let's go with the information that we know. We know that sine is -5 over 13. Now remember, your hypotenuse is never going to be negative, so we know sine is going to be negative. So we go and take that. So that's going to be, well, I'm going to have to rewrite this anyway. So that's -5, and that's 13. Now, we don't know what our adjacent side is. So therefore, we can either use Pythagorean Theorem or look for it in a Pythagorean triple, which hopefully 13 squared, or let's do, so if we did Pythagorean Theorem, a squared plus b squared equals c squared, leg squared plus leg squared equals c squared. Let's call this a. So if you did a squared plus -5 squared equals 13 squared, you'd have a squared equals 25. A squared plus 25 equals 169. Subtract 25, subtract 25. A squared equals 144. Square root, a equals plus or minus 12. And hopefully you would have already known. If you didn't, I just figured I would do it, that 5, 12, 13 is a Pythagorean triple. Now, again, since it's in the third quadrant, a is not going to be plus or minus. It's just going to be positive. It's going to be a positive 12, because that's positive over there. So there's our triangle, 12, 13, -5. Perfect. Now, that's going to get in the space of my work. So I am going to redraw that triangle over here and then erase everything else. So that's 12, 13, -5. Remember, that is the opposite side. That's the adjacent side. And that's your hypotenuse. OK. All right. So now let's get into the good stuff. OK, so now we have to evaluate for sine of pi over, or u over 2, cosine of u over 2, and tangent of u over 2. So to do that, we're going to use the half angle formulas. So for sine, the half angle formula is plus or minus the square root of 1 minus cosine of u divided by 2. Now the plus or minus is dependent on where the angle of u over 2 resides. We know the angle u is in the fourth quadrant. But to figure out where the angle u over 2 is, what we can do is divide everything by 2 here. And what I obtain here is 3 pi over 4 is less than or equal to u over 2, which is less than or equal to pi. Well, 3 pi over 4 and u, if you're going back over to those angles, that is residing in the second quadrant. Sine is always positive in the second quadrant. So therefore, we're just going to have the positive version. We're not going to have to, our angle is not going to be negative. All right, so now let's go ahead and plug in our information. So we have the square root of 1 minus, now cosine, remember, is adjacent over hypotenuse. So that's going to be 12 over 13 divided by 2. Main important thing is we want to combine our numerator. So I'm going to rewrite 1 as 13 over 13 minus 12 over 13 divided by 2. Now subtract your fractions. When you're subtracting fractions with the same denominator, you subtract just the numerator and leave the denominator the same. So that becomes 1 over 13 divided by 2. Now, to simplify this, I can multiply by the reciprocal of my fraction in the denominator. And what that's going to leave me with here is going to be that multiplies to give you 1. So I'm left with 1 over 26. OK, let's continue. Now, when you're taking the square root of a fraction, you can break that up into the square root of the numerator over the square root of the denominator. So really, I have square root of 1 over the square root of 26. Well, that obviously equals 1 over the square root of 26. We don't like to leave our answer with the square root in the denominator, so I'm going to rationalize my denominator. And that's going to leave me with the square root of 26 over 26. And I look into simplifying this. I try to look into, is there any square numbers that divide that I can simplify that? And the answer is no. So that's going to be my final answer. Now let's get into cosine of u. Now cosine is going to be exactly the same case. We're going to use, the formula is just a little bit different, but it's plus or minus 1 plus cosine of u divided by 2. Now again, the plus or minus depends on where u over 2 is. Well, again, look at u over 2 is between 3 pi over 4, and pi. So that means u is now going to be negative. So we're going to want to make sure we keep that negative sign. Every single time I write the radical, I got to keep that negative. All right, so now let's plug in our information. Negative, so it's 1 plus cosine of u. Again, cosine is 12 over 13. So it's 1 now plus 12 over 13 divided by 2. Again, I'm going to combine my fractions. So I'm going to rewrite 1 as 13 over 13 minus 12 over 13 divided by 2. Subtract those fractions. I get 1 over 13 divided by 2. Multiply by the reciprocal, or rewrite that as a 1. So I multiply by the reciprocal on the top and bottom. And now what I obtain here is that divides the 1, and I'm left with a 1 over, what happened here? That should not be the same. That's a plus. What happened here? Why did that change to a plus? That's plus. That should be 25. Multiply by 1, and what I get is 25 over 13. Negative square root of 25 over 13. OK, good. Then I go and break it up just like I did before. I'm going to take the square root of the numerator over the square root of the denominator. Well, I can take the square root of 25. I cannot take the square root of 13. So I'm going to leave that as is. However, I can rationalize the denominator. And by doing that, I now obtain 5 square root of 13 divided by 13. And I cannot simplify that no further, or any further. So that's going to be my final solution there. All right, last one is going to be tangent. So tangent, again, we could use the formula where it has the square roots on both of them. Or we can use our other ones. And the one that I've been most often using is the one where sine is in the denominator. So that formula looks like this. 1 minus cosine of u divided by sine of u. And the reason why I like that one is I just like having the one function in the denominator rather than 2 like the other one. However, in this one, I have to evaluate for cosine and for sine. That's why I did the Pythagorean Theorem earlier. So I can now use this triangle to evaluate for sine and cosine. I should have shown where u was, or alpha, or u. So 1 minus cosine, remember cosine is 12 over 13. So it's 1 minus 12 over 13 divided by sine, which in this case is negative 5 over 13. OK, again, numerator, it's like the same thing over and over. It's almost like Groundhog's Day. Combined, get the same fraction. And I'm showing a lot of my work here. That subtracts, right? It is subtracting, right? 1 minus, yeah, you're subtracting. So therefore, that becomes now 1 over 13 divided by negative 5 over 13. You could divide out the 13s, or if you don't believe me or haven't done enough work, let's just multiply by the reciprocal. Now you can see that any fraction multiplied by reciprocal is going to go to 1. Now you can see that the 13s divide out, and we're left with a negative 1/5. And there you go. So there you go, ladies and gentlemen. That is how you evaluate the expression using the half-angle formulas when given an equation and constraint. Thanks. Hello.